Poland, August 1943. A German supply column moves along a forest road east of Krakow. Speed, roughly 40 kilometers per hour. The lead vehicle passes a shallow depression in the soil. Nothing marked. Nothing visible. 12 seconds later, the road beneath the second vehicle ceases to exist. The explosion lifts the rear axle of a 3-ton Opel Blitz truck 2 meters into the air. Then the frame collapses into the crater. The device that caused this cost nothing. Assembled in a farmhouse cellar. Less than 1 hour. A glass water bottle. A stub of a tallow candle. A length of safety fuse. Captured German explosive. The timer was flame. The trigger was gravity. By conventional standards, the engineering was almost too simple. It worked. Every time. By 1942, resistance movements did not lack will. They lacked means. SOE and OSS were inserting agents and supplies. But drops were unreliable. Dangerous. Limited. A Sten gun. Plastic explosive. Finite quantities. What cells required were weapons they could fabricate themselves. From materials in any village. Any farmhouse. Any hardware store. The improvised time delay mine answered a question regular doctrine never asked. How do you arm a civilian with nothing? The candle delay mine was not a single design. It was a principle. A candle of known diameter burns at a predictable rate. A household tallow candle, 20 millimeters thick, burns roughly 12 to 15 millimeters per hour. Cut to length, it becomes a clock. 30 minutes, 2 hours, 6 hours. Accurate enough to put kilometers between the operator and the blast. In clandestine warfare, distance equals survival. Construction sequence. A glass bottle, 500 milliliters to 1 liter. Cleaned. Dried. Primary explosive charge inserted. Often captured German Sprengkörper 28 blocks. If unavailable, ammonium nitrate and fuel oil. Packed in cloth or paper. A safety fuse attached to a detonator. Burn rate standardized. 30 seconds for 30 centimeters. Detonator crimped by hand. Sometimes with tools. Sometimes with teeth. A practice that injured many operators. The free end of the fuse placed against a candle at the calculated point. Candle lit. Operator leaves. Candle burns. Reaches fuse. Fuse ignites. Flame travels to the detonator. Detonator fires main charge. If the bottle is intact, glass fragments add to the blast. If buried beneath the road surface, force directed upward. Against the railway track, the expansion wave exceeds the steel's tolerance limits. Against fuel lines, secondary ignition exceeds primary blast. All required supply chains. The candle required a village. Failure modes existed. Wind reduced burn rate. Rain extinguished the flame. Animals or soldiers moved devices. Outdoor failure rate estimated 20 to 30%, mostly flame extinction. Indoor industrial placements far more reliable. There was one further consequence. No identifiable timing mechanism remained. A derailed locomotive could be logged as fatigue, a collapsed transformer as an electrical fault. In 1942 and 1943, German occupation reports recorded incidents misclassified as accidents. Only decades later did historians reclassify them as sabotage. Between 1941 and 1945, SOE delivered approximately 1 million kilograms of explosive material to resistance networks. The amount of candle wax consumed in the same effort was never recorded.